So get this. We're about to dive into a breakthrough that didn't come from some massive AI lab or a tech giant. It came from a game developer, a novelist, and a math teacher who goes by Shadow K, and he was just trying to figure something out. Why do these big creative AI models sometimes just suddenly start acting in a totally stable, predictable way? The answer he found? Well, it could change everything about how we work with AI. And this is where it gets wild. This is the core of his discovery. When you give an AI a certain kind of structured input, it stops treating your words like a suggestion or a creative prompt. Instead, it starts treating them as the fundamental, unbreakable laws of physics for a world it's simulating in its own mind. It's not just reading the rules, it's living by them. So, that's the big puzzle we're going to solve here. How can something as fluid and, unpredictable as a creative AI be locked into this stable, consistent state, using nothing but plain English? What's the secret to turning a storyteller into a simulator? To really get this, we first need to wrap our heads around a whole new concept, the idea that language itself can act like an operating system, or even a physics engine for an AI's internal world. It turns out an LLM basically has two modes it can operate in. We're all familiar with the creative mode on the left. It's an amazing storyteller, but it's all over the place, totally inconsistent, and loves to make stuff up. The big discovery here is the simulator mode on the right. When you trigger it in just the right way, the AI stops making things up and starts calculating. It just executes a set of rules with this incredible, rigid consistency. And the method for making this switch happen is called a Natural Language Constraint System, or NLCS. Now, this isn't just some clever prompting trick. It's a formal system for writing rules, in plain language, that the AI feels compelled to treat as absolute law. This is how you give a digital mind a fixed, stable reality. And this isn't just a theory. The author actually went and built a working prototype, a complete world engine called the S engine, just to prove that NLCS is the real deal. The S engine is built using 5 distinct layers of rules, and every single one is just written in natural language. It starts at the bottom with the most fundamental laws, kind of like a physics engine for combat, and then it builds up to more complex systems like how things grow, what actions they can take, how they move, and even a whole resource economy. Each layer is separate, and each one is treated as law. So the big question is, why does this work so well? What is actually happening inside the AI's brain that makes it follow these language-based laws so strictly? Well, the answer seems to come down to 4 key principles that the author figured out. First up is hierarchy. This sounds almost too simple, but just numbering the rules is a huge deal. The LLM gets it. It understands that rule 001 is more important, more fundamental than rule 002. This simple little trick creates a stable, logical structure for the AI, and it stops rules from ever conflicting with each other. Second is domain separation. So by keeping the rules for, say, combat completely separate from the rules for the economy, the LLM automatically organizes its own thinking. It creates these different subspaces in its mind and understands these are totally separate systems that shouldn't mess with each other. It brings a ton of order to its reasoning. And this brings us to the coolest concept of all, vector gravity. That's the author's name for what happens when the rules are clear, logical, and well-structured. That language acts like this powerful gravitational force, pulling all the chaotic, scattered ideas inside the LLM into one single, stable, focused state. All the ambiguity just disappears, and the model is forced to converge on the one correct interpretation of its world. And finally, there's state transition. The rules are all written in a super simple if this, then that format. For example, if health is less than 50, then attack power decreases. Turns out, this simple conditional logic is a pattern that LLMs are incredibly good at recognizing and following, creating this powerful, reliable flow of cause and effect. So when you put all of these pieces together, it becomes really clear what's going on here. We're not just looking at a better way to prompt an AI. No, we're looking at an entirely new way to program one. And this is the crucial point, right here. NLCS is effectively a new kind of programming language. It has variables like health or resources. It has functions like decrease or calculate. It even has loops that run over turns in the simulation. The only difference is that the syntax isn't code, it's just structured, logical, plain language. This chart from the source material just drives the point home perfectly. On one side, you have traditional prompting. It's a command, You get a short-term reply, and you have a really high chance of the AI just making stuff up. On the other side, you have NLCS. It's not a command, it's a law, and it enables long-term simulation with almost zero hallucinations. I mean, the difference is just night and day. And the results are genuinely astonishing. It's not just that hallucinations are basically gone, but the whole system is predictable and consistent. But here's the real kicker. The S engine produces almost identical results on GPT, on Claude, and on Gemini. Now, that level of consistency across different models, that was thought to be pretty much impossible. It proves the power is in the structure of the language, not in the specific AI model you're using. So that leads us to our final section, because a discovery this big doesn't just have technical implications. It has these profound strategic ones that could seriously reshape the entire global AI landscape. The author argues that this changes the whole game. For years, the AI race has been about who can afford the most GPUs, who has the biggest data centers. It's been a competition of server capital. NLCS flips that. It shifts the focus to brain capital. Suddenly, the most important skill isn't building the model, it's designing the rules that govern how it thinks. Now, the author, who is Korean, makes a pretty compelling case for why his country might be in a unique position to lead this new wave. He points to the logical, hierarchical structure of the Korean language itself, a deep cultural expertise in designing complex game worlds, and a fast, iterative dev culture, all things that are perfect for mastering the art of NLCS. And this quote from his white paper just perfectly captures the potential power shift here. It paints a picture of a future where one country might build the raw engine, the AI itself, but a completely different country writes the software, the very laws of logic that makes it useful and decides what it does. And that leaves us with one last fascinating question to think about. In a world where AI is governed by these natural language rule sets, is the real power with the person who builds the machine or the person who writes its constitution? Something to chew on.